Download this code from codegive.com, link in the description below. OK, let's dive into the quirk and potential bugs surrounding the use of Boolean arrays as quantile arguments in Pandas quantile function, especially as it relates to its reliance on NumPy's underlying quantile implementations. This is a subtle area that can lead to unexpected results if you're not careful. Understanding the issue. The core problem revolves around how Pandas, specifically the quantile function, interprets Boolean arrays passed as the q parameter, the quantiles to be computed. While you might intuitively expect it to select values based on true indices in the Boolean array, the behavior is different, and it's rooted in how NumPy's quantile functions, like np.percentile, np.nanpercentile, etc., handle numeric quantile values. The Boolean array gets implicitly converted to numerical representation, true-1, false-0, and those are treated as quantile values. Background concepts. Quantiles. A quantile is a value below which a given proportion of observations in a group of observations falls. For example, the 0.25 quantile, or 25th percentile, is the value below which 25% of the data lies. NumPy's quantile functions NumPy provides functions like np.quantile, and its variants, to calculate quantiles. These functions expect the q parameter to be either a single float, representing a single quantile like 0.5 for the median, or an array of floats, example 0.25, 0.5, 0.75 for the quartiles. Pandas quantile method. The Pandas quantile method, available on series and data frames, is a convenient wrapper around NumPy's quantile functions, providing a user-friendly interface for calculating quantiles on Pandas data structures. The problem with Booleans as quantiles. When you pass a Boolean array as q to pdSeries.quantile or pdDataFrame.quantile, here's what happens under the hood. 1. Implicit conversion. The Boolean array is implicitly converted to a NumPy array of integers, zeros and ones. True becomes 1, and false becomes 0. 2. Interpretation as quantile values. These zeros and ones are then interpreted as quantile values, similar to if you had passed q equals 0, 1. This means you are computing the 0th percentile, minimum value, and the 100th percentile, maximum value. 3. Unexpected results, especially with interpolation. If you're using an interpolation method other than linear, or have many duplicate values, the result might not align with your expectations if you were expecting Boolean indexing/filtering. Code examples demonstrating the issue. Explanation of the examples. 1 basic example. The first example shows that passing data 5 as the q parameter to data.quantile doesn't filter the data. It calculates the 0th and 100th percentiles, min and max, multiple times because the Boolean array is converted to 0, 0, 0, 0, 0, 1, 1, 1, 1, 1. The correct way to filter the data is using Boolean indexing, data 5. 2 interpolation methods. The examples with interpolation illustrate how different interpolation methods can lead to different results. The interpolation method determines how the quantile value is calculated when the desired quantile falls between two data points. With the above series of 1, 1, 1, 2, 2, 3, 3, 3, calculating the 0 and 1 quantiles will return the minimum and maximum values respectively. 3 data frame example * demonstrates applying this concept to a data frame. Be mindful of which columns you're applying the Boolean mask to and which columns you're calculating quantiles on. Why is this happening? This behavior isn't necessarily a bug in the traditional sense, although you could argue that it's counterintuitive. It's more of a design choice in NumPy and how Pandas leverages NumPy's quantile functions. The implicit conversion from booleans to integers is a standard practice in NumPy. The intention is likely to provide flexibility in using numerical arrays directly as quantile values, even if they happen to contain only zeros and ones. The Pandas quantile method inherits this behavior. Best practices and solutions. 1. Avoid booleans as direct Q arguments. The clearest solution is to avoid using boolean arrays directly as the Q argument to quantile. Instead, use boolean indexing/filtering to select the data you want to analyze before calculating quantiles. 2. Explicitly convert if you really want quantiles 0 and 1 *. If you truly intend to calculate the 0th and 100th percentiles and want to use a boolean array, explicitly convert it to a numerical array, example boolean _array.astype, int, and then use that as the Q argument. However, this is rarely the desired behavior when you're starting with a boolean array. 3. Clarity through intent *. Make your code as clear as possible. If you're filtering data, use boolean indexing. If you're calculating quantiles, use numerical values for Q. 4. Double-check your results * Whenever you're working with quantiles and boolean masks, it's always a good idea to double-check the results against what you expect. Print out the boolean mask, the filtered data, and the calculated quantiles to ensure they align with your understanding. Example of correct usage with boolean indexing. In summary, be aware of the implicit conversion of boolean arrays to numerical values when using them as the Q parameter in Pandas quantile function. Avoid using boolean arrays directly as Q unless you specifically intend to calculate the 0th and 100th percentiles. Use boolean indexing/filtering to select the data you want to analyze before calculating quantiles. This will help you avoid unexpected results and write clearer, more maintainable code. Always double-check your results to ensure they align with your expectations.